So let's see the role of water in showing acidic and alkaline property. Okay, like in acid. So when acid is dissolved in water, the hydrogen atom in the molecule of acid will release as hydrogen ion. So the hydrogen ion is the function group for acid. Okay, so the more acidity it is, the more hydrogen ion it can be dissolved up. Okay, so in terms of Arrhenius' definition of an acid, he said it's a chemical substance which ionizes in water to produce hydrogen ion H plus. Like for example, hydrogen chloride gas is a covalent compound and exists in forms of molecule. So when it dissolves in water, hydrogen chloride molecule will ionize to hydrogen and chloride ion. So the aqueous solution is called hydrochloric acid. This one. Okay, so HCl will become H plus plus Cl minus, where H plus is the acidic group. Okay. Or you jot down this one first. Done, huh? Okay. Now let's see the next part. Huh? So an aqueous hydrogen ion will combine with water molecule to form a hydrozonium ion, which means it's H3O negative, positive, sorry, H3O positive in aqueous solution. And this one we commonly write as H plus, H positive only, because they just like this one you see, you see, they just attach only. This one moves to here is just attached because this hydrogen, the new hydrogen, is highly unstable. So it can break up easily. So you can consider it's just attached like this. Okay. So to give an acidic property, the real ion presence in the aqueous solution are the hydrozonium ion. But to make the description easier, so normally we just say hydrogen ion is often used. Okay.
So the hydrogen is the
hydrogen as in this case for acid is the hydrogen ion. Because somehow when you add something inside to react with it, it will automatically detach from the hydrozonium ion. So the hydrozonium ion will go back to water. So the only one that involved is actually the H plus. That's why we all consider it as hydrogen ion. Okay, all right, jot this down. Okay, this one you need to draw. Okay. Nana. So then let's look basicity of acid. So basicity of acid, okay, is actually refers to the number of hydrogen ion that can be produced by 1 mole of acid ionized in water. Okay, so it means that how many mole of hydrogen ion by 1 mole of acid in aqueous solution. So for example, sulfuric acid, it can create how many mole? H2 SO4, right? So H2 means that it can release two mole of hydrogen ion. So that's why its acidity is higher than hydrochloric acid. But sometimes you have to take into consideration on the solubility of the acid as well. Some acid which is partially soluble, so it's a weak acid. Why is although it can release maybe 3, but because the what you call the solubility is too low, so the basicity of acid will be very low as well. Okay, all right. So jot down this one first, then we go to the next one. Okay, like this. So jot down this one first. Done, huh? So let's see the types of acid. Like monoprotic acid. Monoprotic acid means that in the S when it's soluble, completely soluble, it will release 1 hydrogen ion. Diprotic release 2 Di. So when 3 is triprotic acid. So for the monoprotic acid, it's the acid that produces only 1 hydrogen ion per molecule in water, like hydrochloric acid, nitric acid, and ethanoic acid. Diprotic acid are those that produce 2 hydrogen ion per molecule in water, like sulfuric acid and ethane dioic acid. Okay, and then triprotic acid is the one that produces 3 hydrogen ions per molecule, like phosphoric acid. Okay, but phosphoric acid, this doesn't mean that phosphoric acid has higher acidity than sulfuric acid, because like ethanoic acid, phosphoric acid, and ethane dioic acid are those acids we call weak acid, where it doesn't dissolve completely in water. Okay, so the one with the highest acidity should be sulfuric acid. Okay, because like strong acid, HCl and sulfuric acid, these two are dissolved completely in water. Okay, all right, jot this down. Done, huh? All right. So let's like formic acid is used in latex coagulation. So although a molecule of formic acid has two hydrogen atoms, but the formic acid is still a monoprotic acid because only one hydrogen ion can be produced by one acid molecule when ionized in water. Okay, this kind of case is because the how to say, when dissolved in water, one of it has two hydrogen atoms, but one is strongly bonded. Another one is released only. Okay, so next we talk about alkalis, or in short we call base. Okay, base is a chemical substance that react with acid to produce salt and water only. So, like for example, metal oxide and metal hydroxide are base. Okay, like magnesium oxide with react with sulfuric acid will create magnesium sulfate, which is the salt, with water. Calcium hydroxide with nitric acid will create calcium nitrate with water, where this calcium nitrate is salt. Okay, salt doesn't necessarily doesn't contain metal. Salt is actually mixed up of ion and means that cation ion and anion. So they are metals. Like the salt that we eat, sodium chloride, right? Sodium is actually a heavy metal. Okay, so these are considered base because both substances react with acid to produce salt and water only. Okay, so alkali is a base that is soluble in water and ionized to produce the hydroxide ion. Just now, hydrogen ion is the active group for acid, right? So OH negative is the active group for alkali. So sodium hydroxide is an alkali because it dissolves in water and ionized to sodium ion and hydroxide ion. So the sign is a alkali. Okay? All right, jot this down.
Yes, sir.
Okay. Wait lah. Okay, so let's continue. So this is how this happen. I have been showing too much. Like the salt is there, you add water, so it break up into ion. Okay, very easy one. So no need to. All right, so Arrhenius definition of an alkali. So means that it's a chemical substance that ionized in water to produce hydroxide ion. As long as it's hydroxide, then it's considered as a what you call is considered the alkali. Right now, for example, the reaction between the ammonia gas and water. So the aqueous ammonia gas is alkali. Why? Because the molecule of when ammonia undergo ionizations, produce hydroxide ion. Right, ammonia gas NH3 plus water become ammonium NH4 positive plus OH negative. This is why ammonia is corroded. It's something that corrosive, not corroded, corrosive, because ammonia when become ammonium, it becomes alkaline, but it is corrosive because NH4 positive is the one that get positive is actually one of the what you call one of the water molecule goes to the ammonia, so it makes it got acidity, some of the acid what you call acid, it makes it have some of the acid properties, right? Acid is corrosive, but somehow ammonia also contain corrosive what you call corrosive property because of this. So this is why alkali did corrode, but not as strong as acid. Because during the formation of alkali, there must be a part who become positive. So it will corrode, but not that strong. Okay. All right, write this down. You better write this, huh? No need to draw this one, just write this one only. Done, huh? So the formula you have, this one you already jot down like this on top. So we just, so let's see some uses of acid, bases, and alkali. So like metanoic acid, they use it for coagulate the latex, so to make it solid. Carbonic acid, this is the one that used for fizzy drinks, like your what you call Coca-Cola, all this. Okay. Nitric acid, they use it for fertilizer and explosive. Actually, your ammonia, after you took out some of the part, you can use to make explosive as well. But the very old one, the one that last time chocolate color one, one piping one, and the very old one. Yeah, not nowadays one. Nowadays explosive no longer using this one. Okay. Sulfuric acid, they use it to manufacture detergent, paint, and also the electrolyte for the lead acid accumulator. The lead acid accumulator are the what you call the car battery. Okay. Magnesium hydroxide. This one is alkali or base. They use it to make antacid. Okay. And you know what's antacid? Don't know. Antacid is actually the one of the pill. Okay, the one that we eat to neutralize your acid in stomach one. The gastric one, the ubat gastric. Normally, you see in white color, like Gaviscon. Gaviscon, they contain this kind of thing. And then you have a calcium oxide or calcium hydroxide. They use it to neutralize the acidic soil. They mix it with the soil. Normally, they call batu kapur. Okay, sodium hydroxide to manufacture soap. Okay, aqueous ammonia. This is to manufacture the washing agent. This washing agent is towards those very strong dirt, where they spray some of the I think you never seen normally on this kind of thing. They normally use it in industry because it has a very what you call very strong smell. Ammonia, the smell is like your school toilet without washing for 10 years. That's the smell. Okay. All right, jot this down. Done, huh? All right, now let's continue. So let's see the role of water to show the acidity and alkalinity. So an acid shows the acidic properties when it's dissolved in water. So acid molecule ionized in aqueous solution, okay, to form the hydrogen ion. And the presence of hydrogen ion is responsible for the acidic properties. Like HCl, with water, it will become hydrogen ion in aqueous, and what I call that, the chloride ion in aqueous. Okay, so because of these water, then they are able to detach. Why? Because water has a what I call that already. There are two properties. One is the what I call already the one that the oxygen that can target one hydrogen. You remember the in biology we have mentioned before the what I call, I forget the name already. We But that oxygen, because it can target one hydrogen, so it can attack the hydrogen. This is why when dissolved in water, the hydrogen has been took out because water's property. This is why the acid only show acid in water after dissolved in water. If in my God, in normal condition, the crystallized one, it is not corrosive. Okay, you understand? So the medium here is water. There must be water. All right, so jot this down. Done, huh? So let's see the experiment. So when we try to see whether the water is needed to allow the acid to show the acidic properties. So what they do is they use a solid oxalic acid with another one is the solid oxalic acid with distilled water. Then I use the blue litmus paper to test the acidity. So of course, the solid one does not change the blue litmus paper. But the one with water, distilled water, means that the dissolved oxalic acid, the color of blue litmus paper turned red. So the main idea for this one is because the oxalic acid only show the acidic property in the presence of water. So without the water, solid oxalic acid only exists as a molecule and hydrogen ion do not present. Okay, so blue litmus paper does not change the color. But when it's dissolved in water, acid molecule will ionize to produce hydrogen ion. So with the presence of hydrogen ion, okay, will cause the acid to show the acidic property. That's why the color of blue litmus paper changed to red. Okay, so the operational definition of acid is we are trying to say that thing acid is the responding variable when manipulating variable. So it's it's a substance that changed the blue litmus paper to red when blue litmus paper is dipped on acid that is dissolved in water. You see? So it's actually the result of responding variable when how we control the manipulating variable. That's the operational definition. That's the template. You must try to remember. Okay. All right. So jot this down. This one, this is to for you to understand how to answer the questions. So maybe you have to copy the questions for this one. And the operational definition of acid in this one is for you to understand the what we call the template or we call the structure of answer. Okay. Okay. All right. So let's see. So without water, so dry acid, it exists as covalent molecule. So the hydrogen ion does not exist. So this is why it does not show the acidic properties. Okay. So when hydrogen chloride gas is dissolved in water, so hydrochloric acid is produced. So the hydrochloric acid ionizes in water to form hydrogen ion. So the hydrochloric acid can show acidic properties. So when they dissolve in organic solvent like methyl benzene, so the hydrochloric gas exists as covalent molecule because there's no water molecule to drag the hydrogen out. So that's why it still exists in molecule. So your hydrogen ion do not exist. Yeah, the adhesion and cohesion force, like this one are the cohesion. Because of this cohesion, so it broke up the. So it's like this one, the hydrogen thingy. So you, oh sorry, this one I draw wrongly. Is actually the terbalik. He attached to this hydrogen. So the hydrogen later on will be break. Okay. So this is why it does not show acidic properties in we call the organic solvent. Okay, can you understand?
So what is the methyl benzene?
Methyl benzene is a kind of organic solvent. Normally, in your case, is the organic solvent that involved is only methyl benzene. Methyl benzene is like water is a solvent, but it's a non-organic one, inorganic solvent. So the methyl benzene those solid is a why we call it as an organic solvent because it's made up of CH and O only. Other than that, all are non-organic. Inorganic now we call. Okay. All right, note this down. Done, huh? All right. Now, so same goes to alkali. Alkali only shows alkaline property in the presence of water. So the alkali will dissolve in water to produce hydroxide ion. So the hydroxide ion is responsible for the alkaline properties. Like I said, the active group. Okay, so jot this down. I think next one we're going to talk about some examples already. Yeah, jot this down. Okay, so let's see the example. So Barium ion and hydroxide ion in solid barium hydroxide are attracted to each other by strong electrostatic force. So they are not able to move freely. That's why the solid barium hydroxide ion does not show its alkaline property. But when it dissolves in water, the solid barium hydroxide ion will ionize to form barium ion and hydroxide ion. They are able to move freely. Okay, so with this, it becomes alkaline. You understand? Okay, so next. So when dissolved in water, we are talking about the one with this one. So when dissolved in water, the ammonia gas will ionize to form ammonium ions and hydroxide ion. They are able to move freely. Therefore, aqueous ammonia solution will show the alkaline property due to the presence of hydroxide ion. So when dissolved in propanol, so the ammonia gas exists as covalent molecule and what you call that? The exists as covalent molecule. And what you call the hydroxide ion does not exist. So the ammonia gas does not show the alkaline property. Sorry, because the drawing when I was trying to convert, I don't know why suddenly the drawing moves up. Okay. So normally the question they ask, they will ask you how the molecule show the acidity or alkaline. So it's like you need to mention, is there any free ion? Okay, so it will force the attraction or for alkaline or the covalent of acid, okay, to break up into hydroxide ion or this hydrogen ion, which will convert to acidic or alkaline property. Okay, can this is the how we answer the structure of answer. Okay. Done the thing now? Okay, so try this one. Make this your homework. Shall I? I think I will capture and send to you.
Yes.
Okay. Okay, 有看一下。Okay, then you're allowed to dismiss. Bye bye.